So this proof is a little more complicated than the other two. So I am going to try to show you in the shortest video I can, but I want you to take a look at what the given is. And I want you to realize also what the proof is. In this, the proof is that you want to prove CE congruent to DF. So in order to do that, we really want to focus on what triangles we're trying to prove. So hopefully you see after realizing that it's EDC and DFC are the two triangles that I'm trying to prove congruent. So what I'm going to do is redraw those triangles and separate them. So pause the video, separate your triangles, and that's what I did. So I redrew EDC and FCD. And one thing as I redrew that, I already noticed that CD is congruent to DC because they're overlapping. So I already know that this and this are the same after my given. So I definitely have to write your given, and then I'm definitely going to write DC congruent to DC right away because I see that as reflexive. The next thing is I'm going to go back up to my given, and I tell you that EDC is congruent to FCD. Well, that happens, both of them happen to already be in my triangle, so that's great. So that's congruent to that, and that was in my given. And then I tell you that E is the midpoint of AD, and I tell you that F is the midpoint of BC, which tells me that this and this is congruent, and it tells me that and that is congruent. It does not tell me that they're the same yet, but my other given tells me that this segment and this segment are the same. So looking at this, we should realize that, yes, they have to be the same. Let's say the segment was 10 and BC was 10, then we obviously know both those segments are 5, and therefore we know ED and FC are definitely congruent. But we have to show that step, and it's not that easy. We have done this before. We have used segment addition, and that's exactly where we're going to start. So you should be able to line up segment addition showing AE plus ED equals AD, and BF plus FC equals BC. So go ahead and do that. So that's our segment addition postulate. Now what I have to do is get the fact that I need ED to be congruent to FC. And I know that AD is congruent to BC. So I am going to, if I know that these are the same, then I'm going to set AE plus ED equal to BF plus FC. And that's all by substitution. And now I'm going to double substitute on each side. I'm going to say that I know, remember that I want ED congruent to FC, but I know that BF is the same as FC, and I know that AE is the same. So I am actually going to make this ED. I'm going to make this FC and FC because I don't want to get rid of FC and that's by substitution. I don't want to get rid of ED and FC because that's what I'm trying to show congruent. So now this is 2ED, and this is what we really haven't done in a while since chapter 2. So I'm going to put them together, and that's by simplifying or combining like terms. And then lastly, I can get rid of the 2 by dividing on both sides. So now ED is equal to FC, and that's by division. I got rid of it. And then at this point, it's okay to say ED if I'm being textbook correct, FC by definition of congruence. And then lastly, I have enough, if I go back to my triangle, now that they're congruent, take a look, and why would these two triangles be congruent? Hopefully you realize it would be side angle side. So I'm going to say triangle EDC congruent to triangle FCD by side angle side. And then, of course, after the triangles are congruent, I can say anything else is congruent, what they want us to prove, by CPCTC. Okay? Hopefully that helps.